My name is Nisha Riyaj. I work with Oracle MySQL as a principal solution engineer. Today's topic that we are going to talk about window functions in MySQL. I'm not sure how many of you are using SQL analytical aggregate functions in our reports or daily statements or programming, whatever that you are using. But I'm going to cover very high level. Window functions can be complex, that you can write complex algorithms with the, calculation and very useful complex SQL that you can write. But I'm going to cover only high level because I don't use it as every day. I'm a DBA, I'm not a developer. Sorry about that. It's kind of the other side of the, road. So it's very helpful for developers that if you are into it, like you want to build up on top of it. So I'm here just to share what is available in MySQL. I've been working as a DBA and allowed to travel, of course, and need some local food. That's why I'm in Pasadena trying to find some local food here. I don't know. I'm a vegan as well, so that makes it harder for me to go everywhere. So. And of course, long walks and yoga helps me to keep my mind clean. So window functions is aggregate functions, as you know, and some analytic functions, which is non-aggregate function. So we are going to talk about high level again, few examples, and I was planning to do some demo, but I don't know if you all can see the font. If I have time, and I can show a couple of statements in demo so you can see hands-on how it looks and how it works. So here is, what is window function? Why are we saying that, why can't I use a group by class or just a regular function in an SQL statement? So window function actually keeps the result set for each individual row because it calculates using the vicinity of the row to come up with that value. So the group function actually, group by class, actually sums up and gives you one end value. So window function is for each row that you will get a value corresponding to that row using the window function that it's been applied to. So that is the beauty of using a window function in your select statement. So for this demo or the presentation, I have to have some data set up. The data that I have is a small schema I created. I'm sorry that you cannot see because of this screen and this display. I don't know if you can read this font, but I created a small database or a schema, which is a very simple. It's called window function demo. And I want to have a couple of tables to play with. One table is called player table, and it has a full name and each player, how many points that they have, and the group, which group that they belong to. This is just a data. And here is a sample of the data. The reason I'm showing you this is that down the road, we are going to calculate the average, or we are going to calculate the ranking. We are going to calculate their, how many points they are lagging behind from the first place. So this is the data that we are going to play with. And another table that I have is books table. It has some book's name, publication ID, and the price, and the language it's been published. So this is the data that we will be playing with. So if you just want to keep some points to remember, the category ID, book, publication, language, so those are all the columns that I will be picking up in our select statement. I'm sure you are aware of many of these functions that you are using it. For example, count, min, max, average. We use this very commonly and regularly in our select statement. So I'm not going to cover all of it. I'm going to cover only a couple of them, which is group concatenate function and the JSON array aggregate function and the object aggregate function. That seems very interesting. What is that? So let's talk about that when we go into that example. The non-aggregate function or analytic functions are listed here that you can find a rank of particular column or the player that we are going to query against, and you can find nth value, or the first value, or the last value, row number. These are all very useful in your reporting, or you were coming up with your running total or average. So you can write this powerful SQL statement or reports using these functions. That's the whole point of this. Like I said, aggregate function, let's look at this. Very simple, selecting the sum of the price from the books table. It gives us the total summary of the book price, which is $390. When we want to group it by the category ID, you can see that it breaks it down by the category ID. This is a regular sum and group by function that we use in our select statement. Why is that different using a window function? So if you look at window function, this is, you see that over class and the over partition by. So when it comes to window function, the over class and the partition by combination defines a window frame for us. That is the syntax that you have to use to create the window frames and the functions. And the same thing, if you look at this, the second line, which says sum book price over, that is the total sum. And then we are summing the book price over, partitioning by the category ID. So it is partitioning or grouping it by the category ID. So that is useful when you want to say, oh, I want to partition it by category ID. So this is how you can see the difference between the regular sum and the window function sum class that you are using in SQL statement. And let's say the group concatenation. You want combine two column values, two row values. So if you want to have a publication ID and you want to find each category ID for that publication, you can use the group concat function as well. This has some restrictions. So the JSON array aggregate function, JSON object aggregate function will help you to get more stylish report in the formatting wise. But in the group concatenate, you can use your custom separator if you want. You can separate by a semicolon or whatever the character you want to separate. So you can use that as a distinct to remove any duplicate values as well. So these are all the various ways of using the group concat, using with a distinct class or separator variable as well. Like I said, the JSON array aggregate. This is very powerful. It aggregates the columns in a JSON format because a lot of programs and a lot of development happening using output as a JSON format. So this is very useful function to use in your select statement as well. If you look at the output, you can see that. So I'm selecting the JSON array publication language for each books and partitioning by the book ID. Look at the format it is giving to us. So this is very helpful to use in our report. So you want to show the results in your table in a JSON format. So this is also using the window. The second picture here I'm using window W as partition by. So that is a window frame class that I'm calling in this select statement. So this is another way of representing your data. So what is the difference between JSON array aggregate, JSON object aggregate? Can anybody see the obvious difference? It requires two values. One is a key parameter, another is a value parameter. So it takes two values. If you don't pass two values, you will get error. So I'm passing a language and the book price. So it is giving it in a pretty format as well. So this is helpful if you want to format your report and show some kind of running totals and using the concatenate and JSON formatting. This is what I'm covering on the aggregate functions. Like I said, all the other regular, like average, sum, count, I'm not going to go over that because you know that, how it works. So the non-aggregate function is interesting because it's kind of applying that row against each row, it will take the rank function, applies that on the each row, and creates the output column. So in this example here, if there is a same rank, it is skipping number 5. If you use the rank function, so we are ranking the players by the point, and then we are giving the player as an overall rank, but you can see that it is skipping a rank when you use the rank function because it's treating us as a peers. So in order to avoid that, because sometimes you don't want to see, skipping numbers, so you can use dense rank function. If you look at, we are using a dense rank over. When it comes to window functions, the over clause is mandatory. You have to use that to partition it or group it or order it. So that is what defines that, like how you want to, calculate these points, sorry. So this is dense rank. If you see that, it is not skipping number 5. So that is the difference between the rank and the dense rank. The partition by, we've been looking at the partition by, I think, in the previous example. But the partition by is the same as the group by, but we are combining the rank, and also we are combining the group by partition by clause. And in here, if you see that it's internally grouping it or partitioning it with the group A and group B and ranking it the players. So basically, the partition by, similar to the group by class, but the way that we are using here in the select statement gives in a different display. So based on what you want in your report, you can look at this partition here. First one is a ranking. Second column is a group name. And the last one is the player within their group, what rank is each player. So that is what we are calculating here. So the partition by has a frame clause that we have to remember. It takes the unbounded preceding rows, unbounded following rows from the current row. So n preceding, n following. So I'll show you an example because this is very confusing if you just look at the number unless you put it in an example. So here is an example for this. So here I'm taking I'm using the frame class, which is rows unbounded preceding, and the second part of it is the current row. So if I'm not using anything following, so that is the current row. So I'm calculating points for each player. Sorry, I can't see from here, hold on. So each player, they're running total and they're running average. So if you look at that, it's taking player number Kevin for group A. Their point is 71.27. That is the sum of the points partitioned by the group name, right? And then rows unbounded preceding, and the default is the current row, is the running total. The second one is average. That means that we are saying that rows between 1 preceding and 1 following as a running total. So it is very self-explanatory that if you look at the last column, it's the average between the preceding and the following row. You can see that. So this is the partition class, partition by. So with the example of how you can use unbounded preceding and following kind of a frame. So it's kind of a moving that running total here. So this is powerful function that we can use in our select statement. Again, this is as complex as you can go to, but make sure that you are using the unbounded preceding and the frames correctly. Otherwise, it will have a wrong results. So remember that, because sometimes we forget, and the actual results, it is not what you're looking for, because you may be missing a preceding class or the boundary for that. So that's a key when you're using the partition by. So make sure that you pay some attention to that. And the first value is a very interesting calculation here. So I have the first value always returns the first value in that partition group. So in this example here, I have points, and then points take away from the first value of the points over partition by group name. So first value is 188.59. So we are subtracting the points from the first value, which is 188.59. So if you do the math here, so that's what the first value we are subtracting it from. So it always takes the first value on that result set. The nth value is another interesting function. It will take two parameters, which is points, and we are mentioning that nth value in this frame, window frame, that we want to use in our calculation. So here I'm showing an example with the fourth. So if you look at this, the nth value here, 4, is 176.34. So until then, it will be null. 1, 2, 3 rows will be null. So that's why I'm using the case statement. If it is null, then return 0. So the first three values are 0, and the fourth value comes, we are subtracting it. Points take away nth value, points come out 4. So then it returns 0. So I'll show you some more example here, because this is nth value is a moving frame. So if you look at this one, I'm using, I removed the case value, so that means that it will show now. So the previous one, if you look at it, it showed 0, because we are using the case value. So if it is case is null, it shows 0. In here, I removed the case statement, so it shows null. So you can see that when you take away the points, take away the fourth point, so I'm showing that the fourth value is 176.34. So first 3 is null, then it started subtracting it. The fourth value is, coincidentally, here is 176.34, so you see 0, 0, and a couple of rows down the road. So that is the nth value function. And here is one more example with 3, because I just want to make sure that we are showing that null is treating with the case statement, it returns 0. The first one was we are using 4. Here we are using 3. So that way you can see the difference that which value it's taking. The third value is 188.58. That's the one that it is taking to calculate the last column. So this is useful to move around this frame. You can understand that how effective this functions that we can use in our select statement. So some more. So I was just playing with the how the frame moves. So I used 4. I removed the case to show now, and then 3, then 0.6. So you see that this frame is moving. So you get the point here. So what is that we are trying to achieve here in this select statement? On the lag and lead, this is also that very interesting that we use lag and lead for calculating the running average, running total or average. So the lag is like any current row lagging, and lead is any row following. It's kind of very confusing when you use it in a regular term, but that is the definition, lag and lead, in the select statement function. So let's look at that example here. So here is a lag points over W as a window frame name. So we can use many window names like W1 or W2, W3. So the reason we are using the window named window is that we can explicitly differentiate which is it representing it. So we can implicitly use a window, or we can name explicitly a window name. So that's what I'm using here as a W, as a window name. And you can see that it is lagging and leading. It's very self-explanatory here that what is the difference. The first one point, take away the lag points. If you look at the first row, there is nothing above it, so it returns null. But the leading is 198.66, so 190.66, it's showing that difference there. So that is a lag lead function call in select statement. The last one is entile. It's very simple. If you look at that, it's partitioning it. The first one, I'm partitioning it only as I'm passing 2. That means I'd put everything into 2 group, or 2 partition. So it's first 15 rows are in 1, and the second is number 2 partition. And when the other one is I'm talking about entile 4, so put it in 4 partition buckets. So 1, 2, 3, 4. So entile is very simple. So it's a bucket kind of a partition that function that you can use as well. So, and also I'm using window W. So that also tells that, it's kind of we are using the window frame call in our select statement. So you can play with that, and the only way we can understand how the frame works, how each function call works, is to create some sample data and move this, windows and numbers and call these functions. So I encourage you to just play with that. Simple data first, and then you can build on top of it as a complex report. So this is what I was talking about, that you can have an implicit window or explicit window. So if you don't mention it, it usually creates an implicit window. But if you want to call explicitly, you give a name and then use that as a column name thing that you can use as well for the explicit window name. There is some restriction that you cannot use the distinct syntax. So this is few restrictions that MySQL has. So, but also with the 8.0.28, it can support up to 127 windows with the given select statement. I don't know who will write that long statement and maintain it. It would be a nightmare to debug it, but I'm sure that it's very powerful report. So there are some references that window function itself in MySQL is only like 5 or 6 pages in the document, but it's very powerful. So again, like I said, I covered high level. I'm sorry about going so fast, and I just want to give the 30 minutes back to you. So thanks for coming and listening to me in a very fast track Windows functions in MySQL. So thank you. Thank you, guys. But check it out, because it's very, I have some demo, but it's very hard to explain it when I'm talking, so that's why I didn't demo it. But it's very, as you roll through with the functions, you will run into like, oh, why is it I'm expecting this results, but this is what I'm getting. So I highly encourage you to play with that. Please do not write any production complex report without playing with that first, okay?